Hi, this is BallGAN 3D-aware image synthesis with a Spherical background. Here are some results from BallGAN. Our model can generate multiple consistent images and extract foreground meshes. Additionally, it can generate multiple consistent foreground masks that capture details such as hair or thin hoop earring. This mask can be used to composite the foreground onto any background. The 3D-aware GAN aims to generate realistic 3D scenes that can be rendered into arbitrary views. During training, the model can only use 2D image collections. Previous 3D-aware generators show good image quality, but they do not learn foreground geometry properly. There is a reason why previous models encounter issues with geometry. It's because the generator employed the nerve backbone and the objective differs. Nerve directly reconstruct the 3D scenes by optimizing the radiance field through multiple images. However, GAN learned to produce realistic 2D images in an adversarial way. Since there is no 3D prior to resolve shape radiance ambiguity, 3D-aware GAN struggled to learn foreground geometry. To solve this problem, we propose a method inspired by popular approaches in 3D graphic community. Here is a 3D graphic showing our motivation. The salient object is a 3D model, but the peripheral landscape, like sky or a tree, is a 2D image drawn on the spherical surface. Even though the 3D space is approximated onto 2D surface, it shows a realistic appearance in the close-up view. This technique ensures realistic rendering. It also reduces overall complexity, focusing resources on the salient objects. We expect the generator with a similar approach to achieve both foreground-background separation and reasonable foreground geometry. Here is the overview of the BallGAN generator. Our generator consists of the two backbone network for foreground and background representation. The foreground model receives the foreground latent code and 3D ray points to output the picture vector and volume density. The foreground network can adapt arbitrary 3D scene representation such as a triplane or nerve. The BallGAN uses triplane from the EG3D. For the background modeling, we approximate the arbitrary sized background to a spherical surface. The background network receives the background latent code and the intersection of the sphere and ray to output a picture vector. Note that our background generator does not predict volume density, because it assumes that the background is an opaque surface. We obtain 2D feature map by a volume rendering feature from each feature field. Then the final image is generated through the super resolution module. We use two regularization techniques. The first one is background transmittance regularization. This loss ensures that foreground and background separate clearly. The next one is foreground density regularization. This prevents the foreground density from diffusing, making the foreground shape clear. Here are the multi-view rendering results and corresponding 3D geometry from EG3D and ours. Unlike EG3D, ours can only get foreground geometry. Our foreground meshes include details like human hair and cat's fur and whiskers. Among the models that separate the background, our model can produce detailed foreground geometry. Next, let's compare the result of real image inversion. Thanks to simplified background representation, our model can capture details such as eyebrow and earring in the foreground meshes. The useful property of our model enables the content creation applications. Rendering the desired foreground on an arbitrary background is one of the applications. Furthermore, our approach significantly improves training stability on datasets with complex backgrounds, such as comp cars. In summary, BallGAN represents the scene with a 3D foreground and 2D spherical background. Our model improves not only image quality but also 3D geometry. Thanks to the ability to separate foreground, BallGAN can be used for content creation and improve training stability on dataset with complex backgrounds. Finally, we show 3D foreground of author obtained by BallGAN. Thanks for watching.